Okay, let's look at the law of segregation. So it says that when a pair of contrasting factors or genes or alleles, allelomorphs, are brought together in a hybrid, the two members of the allele pair remain together without being contaminated, and when the gametes are formed from the hybrid, the two separate out from each other and only one enters each gamete. Okay, so this one is basically your dihybrid cross. Okay, for dominance we did the monohybrid cross. Okay, then law of segregation is your dihybrid cross. Okay, so let's say this is for tall and this is for color. Okay, so in this hybrid, the alleles, they will not contaminate with each other. Means this capital T will separate as capital T, small t will separate as small t, capital Y will separate as capital Y, small y will separate as small y. It's not that capital T and capital Y will go together. No, nothing like that. Okay, they will assort, they will separate from here in the gametes. No, they are pure. Okay, they are in the gametes. No, they are separate from each other. Okay, so these gametes, these alleles or in the gametes, they will remain pure. Okay. So after they separate from each other, only one will enter the gamete. Okay, so let's say, okay, no. I will show you in a monohybrid cross. So capital T has separated, small t has separated in the law of purity. Okay, yeah, this one can be explained by monohybrid cross also. So capital T and small t, they will separate. They will become pure from each other. They are not going, we are not going to start like this. 1 minute. No, it's better like this. Better like this, okay. This one is the male and this is the female, okay. So capital T separate by itself, small t by itself, small t separate, capital T separate, and then when they come in the gamete, this one will go with that, no, and this one will go with this, then this one with this, and this one with that, right? So they will come together and only one will enter the gamete. So from the male here, capital T came, this one, the first one, and which one else came together? This small t from the female one came, okay, and then the other four gametes will form, okay. So you are seeing that this small t and this capital T, they are pure from each other, they have separate, okay. So I think you have understood, no? So pure tall plants are homozygous and therefore possess the gene factors capital T, and the dwarf will possess the genes that is small t, okay. The tallness and dwarfness are two independent but different characters, okay. Pure tall plants will produce gametes, all of which will become tall, and the pure dwarf plants will produce gametes which will become dwarfs, okay. So during fertilization, the capital T will unite to produce F1 generation, okay. That is capital T, small t, means the F1 plants, though tall phenotypically, possess one gene for tallness and one gene for dwarfness, okay. So they have a sort independently, no? And then when they come, they will come like this, capital T, small t, capital T, small t, and capital T, small t, capital T, small t. So although all the four plants, they will appear to be tall, but we know in their genes, in their genotype, they each have a gene for tallness and a gene for dwarfness, okay. So you can see that they are pure, okay. These gametes, these genes, they are going by themselves, okay. They are coming by itself. They are sorting by themselves. It's not that it's depending on another one, okay? It's like you submitted your own answer script, your friend submitted her own answer script, like that. No, it's nothing like your friend and you will submit. One only your friend will submit and the other one you will not submit. It's like that, okay? So this is just explaining what I've already said just now, all right? So we will get a dwarf 1 ratio and a tall plan of 3 ratio, okay? If we if this is the cross, if a hybrid and a hybrid, so this capital T is independent, this one is independently assorting, so also assorting independently. Then on crossing, okay, you will get 3 tall plants and 1 dwarf plan, all right? You do the cross by yourself, you will understand. The results are often represented by the Punnett square as follows, all right? Here, this one. One correction, this one is not, this one is small r, okay? Small r. So you can correct there by yourself, it's easy enough, okay? Okay, so what is the appreciation for the law of segregation? It has been confirmed by cytological study. Cytological means study of the cell, okay? That dominance or no dominance, the law of segregation holds good for all cases, okay? Doesn't mean that just because capital T is dominant, doesn't mean that if it is absent, or the recessive gene will not come, okay? So the recessive gene, it came. How do I say it? Just because this plan appears to be tall doesn't mean that this recessive gene did not come, okay? It had come by itself. It had segregated by itself, okay? So this is the Punnett square. I've sent you in that other note, no, where you can cross it by yourself. So you can try the cross, where you are getting the phenotypic ratio, that is what we appear to have 3 purple and 1 white colored flower. But in the genotype, we have 1 capital P, 2 capital P, small p, and 1 small p, okay? Do you understand by the word phenotypic ratio and genotypic ratio? Phenotype is what we appear, okay? And genotype is what is in the alleles, is in the genes, okay? Here, this is only one type. This is the same type, these two. And this is another type, okay? So the phenotypic ratio is 3:1, but the genotypic ratio is 1:2:1, okay? Because of the law of segregation, okay? Because of the purity of the gametes, thus each gamete will segregate by itself and come into the gamete, okay, to produce the required phenotype that may have the same genotype, but it will have the different phenotype, okay? So I think it's clear. If any doubt, you please let me know.